Hi, everybody. I hope you guys are having a fantastic day so far. So for today, going to talk about energy, how energy can be transformed. All right. Um, so what I'm going to do, and I know you guys have already covered energy, I'm just going to kind of review it and provide you guys some.
Mr. Holtree, call 4045.
And give you guys some background information and the calculations to do so. Okay, so what I'm going to do is present my screen so you can see what I'm seeing. There we go. All right, so what is energy? Okay, what is energy? Now, if you ever need to pause the video at any point, please do so. All right, so energy is the ability to do work. All right, and it can be transferred. Okay, so earlier this year, we talked about the law of conservation of matter, where matter cannot be created or destroyed. Well, and last chapter we talked about momentum. Momentum cannot be created or destroyed. Same thing applies for energy. Energy cannot be created or destroyed. Okay, it's always transferred. So there's two different types of energy. One is called potential, and potential is stored energy. Okay, the energy an object has due to its position, shape, or condition. Okay, and there's two forms of this. Like I said, if you ever need to pause, please do so. The first type is elastic. Now, it's exactly what you think it is. Elastic is kind of like a rubber band. All right, so energy stored in stretched or compressed materials. So energy stored in stretched or compressed materials. The second, and the one we're kind of going to focus in on more, is gravitational. All right, so energy that could potentially do work due to object's position above ground. Okay, so gravitational has an equation. And it's mass times gravitational acceleration, which we already know is 9.81 times the height. Okay. There's all the units. So energy is actually in joules. Okay, energy is in joules. So I want you to try this problem now. Please pause the video. All right, so for the first problem, what you should be getting is 22,318 joules. For the second problem, you got to remember to convert grams to kilograms, and once you do so, you will get about 20 joules. Okay? Now, kinetic energy. Energy due to motion. So whenever something's moving, it has kinetic energy. Okay? Now, there's also an equation, which is 1/2 times the mass times the speed squared, or velocity squared. Okay? There's the units. So energy is joules again. Now, since speed is being squared, it's going to have a bigger influence on the energy than its mass. So if you double the speed, you're actually quadrupling the kinetic energy because it's being squared. And here's a few calculations. So try one of these out. Pause the video if you want to. All right, so for the first one, I got 21,142 joules. For the second one, I got around 81.5 joules. And for the third one, I got about 2.3 meters per second. Okay? So that is energy. Okay? Now, what I'm going to do is I'm going to also post a clip of some long jump. Okay? What I want you guys to do with the long jump is to draw a picture of where energy is. All right, where is energy at? What type of energy? Is there kinetic at the top, at the bottom, in the middle? Where energy is. Draw a picture of it. And then I want you guys to write any questions you might have. Okay? And if you want to share them, you can share them through email or something like that. If not, that's totally fine. Hopefully, in this chapter, we can answer your questions. Okay? Hopefully, in this chapter, we can answer those questions. So that's what I want you to do. Watch the video, draw it out. Where is energy at? Where has it gone? And then ask any questions you might have. Okay? But when you're done with that, you're done. All right? I am not collecting anything. So I hope you guys have a fantastic day, and we will see you tomorrow.